When the weather is like this and there aren't any rifle matches going on, I still do a lot of thinking about high power competition. Some of it is about improving my technique and shooting better scores, but a lot of it is about running better rifle matches or promoting the sport. And some of those thoughts are also about marksmanship in general and just analysis, analyzing things. This video is a little bit different than the ones I normally make, in that it's a look at how I'm analyzing marksmanship and the basics of marksmanship and the basics of the shot process. When you fire a shot, your intent is to hit the very center of the target. But we know that this rarely happens. Most of the time, the shot goes here, 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 or here. Something that I've been thinking about recently is what factors determine shot location? Are some of these factors more important than others? And can I predict group size and score based on these factors? So I came up with a spreadsheet that randomly creates shots on a target depending on the skill level of the shooter, the quality of the rifle and ammo, wind, and potentially other factors. Before we get to that, let's look at the three components of marksmanship. The first is aim. Aim is the center of our area of hold. Wherever our aim is located, our hold is centered to that point. Ideally, our aim is at the center of the target, but this will vary both horizontally and vertically from shot to shot. A newer shooter might have a variation in aim that looks like this, while a more experienced shooter's aim variation would be more like this. If the aim for a given shot is here, the expected result for our hold is somewhere within this blue circle. Once again, the size of the circle or the variation in hold will depend on the shooter's skill level. Just remember that this hold size isn't a true representation of how much the rifle will physically wobble. Rather, it's how far away from the aim point our statistics say the rifle gets when the shooter actually decides to fire the shot. When that decision point comes, the rifle may be pointed here. For the purposes of my spreadsheet, this decision point is simply a point a random distance away from the aim point within the statistical hold area. Once we've reached that decision point with our hold, now we have to get the rifle to fire. A study on shooter reaction time shows that, on average, it takes between 0.2 and 0.3 seconds from deciding to fire the shot to the gun actually going off. Further rifle movement takes place during this period as the hold is continuing to shift and pressure on the trigger will disturb the rifle. As was the case with aim and hold, triggering has variation from shot to shot that depends not on the intended shot location, but on the decision point. Here are some examples of the blue hold point where the decision to fire has been made, and then a quarter of a second later, the red point at which the rifle was pointed when it actually fired. Let's put all that together and review the marksmanship components of a typical shot. We intend to hit the target here, but due to our normal variation, our aim might be here. Variation in our hold will put our shot decision point here. And our trigger control variation means that the rifle will actually fire here. So as you can see, each shot takes one component that makes up a shot, adds some variation, and generates the next component from that. All these components with their variation are stacked up until we get some result for the shot on target. Of course, it's not just marksmanship that contributes to the shot location. Other factors will affect shot placement after the trigger is pulled. The quality of our rifle and ammo and the environment are a couple of examples. But I'm not trying to assess variation on a single shot. I'm trying to see how, over an entire string or multiple strings, variation in each of these factors will impact group and score. To do this, I assign each component of the shot a variation value. This number is commonly known as standard deviation. Let me show you how the standard deviation of shots from the past can predict the location of shots in the future. If you remember, variation from any calculated point in the center of the target determines the location of our shot aim point. Here is our aim point on the target. Now we have to calculate where our shot decision point might fall. This ring represents one standard deviation of hold away from this point. Statistics tell us that there is a 68% probability that our shot decision point will fall within this circle. This ring represents two standard deviations. The probability that our shot decision point falls within this circle is 95%. Finally, this ring is three standard deviations away from the aim point. Almost all the expected decision points in the future will fall within this circle. So the standard deviation helps us to determine the likelihood of a shot falling within a given location. Once we have a shot location, we can determine what value that shot scores. And for a group of 20 shots, we can have a score just like we would in a typical rifle match. Now let's take a look at my spreadsheet to see how all these factors are turned into shot results. Okay, here is my spreadsheet. Just one thing to keep in mind, this is still very much a work in progress. Right now, for example, I only have the 200-yard slow fire stage, which is shot from the standing position in here. And that's only a quarter of the normal course of fire. So I still have the other three the other three components of the course of fire to put in here. But for right now, I think this illustrates what I'm trying to accomplish here pretty well. All right, this is my starting page, and this is kind of the dashboard that leads into everything else that allows me to alter the inputs and get some outputs out of it. So in this column, we have the components that go into a shot on the high-power rifle target. These three, of course, are the components based on marksmanship. And then after that, I've got equipment quality, wind, and then potentially other variables that maybe I haven't thought of. I don't know what those might be, but for right now, I've got them just as three extra variables. And for each shot component, there's a magnitude of variation. And I illustrated what variation was. But in this case, what I'm able to do is for any given shot component, I'm able to vary the variation. And in the case of the components that are made up by by marksmanship ability, the magnitude of variation is changed in this box with this pull-down menu. And for each of these components, I'm able to adjust the magnitude of variation based on what I consider are different grades of shooter ability. So for example, a novice shooter might be someone who is just starting out in high power. An intermediate shooter might be someone who may have a year under their belt. They've kind of got some of the basics down, but they're still progressing. An experienced shooter, I think, is just someone who's been in the sport for a couple of years, and maybe they've kind of reached that one of those plateaus, and now the ability to improve and get their scores better is maybe a little bit more difficult now. And the elite shooter is someone who has got plenty of experience. They have a lot of skill, and they're competing for match wins on maybe a national level. And the perfect shooter doesn't exist. But I have this in here as a way to eliminate variation for a given component. So for example, under a natural point of aim, a perfect natural point of aim means there is no variation in a given shot based on natural point of aim. and I'll kind of explain that a little bit later. But for each of these three components based on marksmanship, they're all the same, where I change the level of a shooter for all of these. And so each one can be altered independently. Beyond that, after we take care of the marksmanship portion of it, another component to the shot is the quality of equipment. So again, in this case, I've got it perfect right now, but this is graded, and these are pretty arbitrary, but I've got as issued, improved, quality, and then of course perfect. As issued has got the most variation, and I see this as maybe if it's an AR-15 based rifle, it's maybe doesn't have a float tube. It doesn't have a free float barrel. It's got a standard GI trigger. Maybe the ammunition is maybe some ball ammo. So that's pretty bare bones as far as equipment goes. Improved equipment is something a little bit better. Maybe a few of the components on the rifle have been modified to competition grade. The ammunition might use better components, like maybe match bullets, for example. Quality would be probably what I would consider maybe the most numerous type of rifle and ammo combo that you might find at a high power match. And that's a rifle that's been outfitted by a competent gunsmith for high power competition. Ammunition that's hand loaded and uses quality, or the best quality components. And so as we work our way up through this list, there's less and less variation from as issued to improved to quality, and then perfect, where again there's no variation whatsoever. And then we have wind. In this case, I've got wind as being there's essentially no wind. These three grades are based on the ability to read wind and correct for it, and that's kind of the key. Is it doesn't really matter how much wind there is. If you can correct for it, then it might be easy. So none means there's no variation due to wind. Easy means a little bit of variation, and then more and more variation. And when the wind is difficult to read and or adjust for, then it becomes difficult, and then there's more variation due to wind due to that. And the wind is only varies the shots horizontally, not vertically. So that's this part of it. And like I said, these variables here, I've got them here as a kind of placeholders, but they don't do anything. So that's that part of it. And then once these inputs are put in, we get some outputs, and the outputs are twofold. There is a target, which in this case again is the 200 slow fire target, and a score. So the 200 slow fire stage has a score, and the other ones I haven't gotten to yet, but I will. So this target is the typical 200-yard target used in high power competition. And on these axes, I've got the number of minutes of angle away from the center. So you can see that the edge of the black is slightly over 3 minutes of angle from the center. And then on this target, a group is generated. The spreadsheet generates a group and plots 20 shots, a group of 20 shots. And based on the position of those 20 shots, it generates a score. Now, in this particular example, there is actually a group of 20 on this target. It's just that because all these inputs are perfect and there's no wind, all 20 shots go through the very middle of the target, and they're all through the same hole right in the middle, which scores obviously a 200 with 20 X's. And that's simply because of these inputs. So as these inputs change, the plot will change, and it's generated randomly based on the variation listed here. And the plot will be generated on the target, and based on the location of those shots, the score is generated here. So just real quick, let me show you where these inputs go and how these inputs lead to these outputs on the target and the score. This is the data behind all these components, these shot components. So here we've got the three components based on marksmanship, natural point of aim, the hold, the trigger control, and then there's equipment and wind. And then each of those components go into a stage of fire. So again, we'll ignore these three stages of fire, the 200 rapid fire, 300 yard rapid fire, and 600 slow fire. We'll ignore those for right now because I don't have those in this spreadsheet yet. But for what I do have in here is standing, 200 yard slow fire. And for each stage, there's horizontal variation and vertical variation. So for example, natural point of aim, here we have the shooter's skill, novice through perfect. And for perfect, there's no variation, even though it's 1/10,000th. We can read that as 0, having no variation whatsoever. So in this example, what I'm saying is, for say an experienced shooter, the natural point of aim component, they have a 1.1 minute of angle. One standard deviation is 1.1 minute of angle in the horizontal direction and 1.1 minute of angle in the vertical direction. And what that means is, based on, if you remember what I had mentioned a little while ago, one standard deviation contains part of what a typical group might be. So in 3 standard deviations, both above and below would contain pretty much all the points that you would expect to find in a group. So again, NPA hold, let's say the elite shooter, their hold might be 0.4 minutes of angle in standing in the vertical direction, which means that statistically their entire hold would be centered on the natural point of aim, but it would vary by 3 standard deviations above that aim point and 3 standard deviations below that aim point. So 3 standard deviation, 3 times 0.4 would be 1.2. 1.2 minutes of angle above and 1.2 minutes of angle below. That's in the vertical direction. And horizontally, we're saying that that one standard deviation is 0.6 minutes of angle. So it would be 3 times 0.6, so it would be 1.8. So 1.8 to the left, 1.8 minutes of angle to the right. Anyway, these are all just numbers that are thrown in here. There's a little bit of method to this madness of these numbers, but for all intents and purposes, these numbers, anybody could argue that these numbers should be different. For example, is the variation due to trigger control for an experienced shooter 0.5 minutes of angle in the vertical direction? Some could argue it might be 0.3. Someone else could argue it's 0.9 maybe. I don't know. But I've got numbers in here just as kind of a guess, and there's a way to get true experimental values for these numbers using an electronic trainer, and that's where kind of some of these come from. But for the most part, they're really just numbers just to generate groups in the spreadsheet. So anyway, that's the data that is used to generate that output. So these are all in minutes of angle, like I said. And so let's go back to this main sheet here. Again, all our components are perfect. There's no variation, which means everything is where we intend to go, which is the very center of the target. But what happens when we start changing these. So let's say the natural point of aim is an experienced shooter. So right away we see that the group is no longer that one whole group. Now we have a group of 20 shots that are a little bit more spaced out. And keep in mind that all we've done is change the natural point of aim. We haven't changed anything on the size of the hold or the trigger control or anything else. So based on this, we would expect a random group to look like this and score a 196 with 2 X's. And we can generate multiple groups over and over again. And again, these are all random groups, but the only change is the variation based on what we input here. So we could change this to, say, a novice shooter, a novice natural point of aim, novice shooter with a natural point of aim, but say a perfect size hold and perfect trigger control. And again, we can just keep generating groups. So just keep in mind that what this means, the natural point of aim, for example, is our intent is to put the bullet right in the middle of the target, but due to variation in the natural point of aim, the aim for this particular shot is right here. And so if we follow that up with the hold, that hold is going to be centered for that shot. It's going to be centered on this point. And so that hold, if the statistical size of the hold of 3 standard deviations, left, right, up, down, might be, say, this big, which means that that decision point from that hold might be here, or here, or here, or somewhere, but centered on this. And then that hold point, it will be the starting point for the variation in trigger control, and so on. So in this case, we could say, well, let's just say it's an intermediate shooter for all these variables. So it's an intermediate shooter for aim, hold, and trigger control. And so the intermediate shooter fires a group of 20 shots in standing and generates a group like this and has a score of 184 with 2 X's. And we can keep generating groups, and we can see how the group changes, obviously, and of course the score does as well. So, and then we can change this to, say, an elite shooter. Shooting standing. Their group is going to be considerably smaller, which stands to reason, and it'll, of course, score higher. And then, this is a good example of a group that there's variation, but it's variation that's not necessarily centered on the center of the target. This group is has a bias a little bit more to the right, maybe a little bit down, maybe. So that's just an example of some of the components that might or the variation that might change on these components. And we can just keep generating groups over and over again if we wanted to. But one question that someone might ask is, maybe you've already asked this, is why? Why do all this? Well, one reason is actually because I like numbers. I like spreadsheets. But a couple of other reasons would be that I want to isolate the components of a shot. So, for example, a shot and it's a group of shots are based on all these components put together. And so your intent is to shoot the center of the target, and the shot actually goes over here, for example, in the 9 ring. Well, when you shoot on a target, you can't isolate these components. You just get the result of the target, of the shot on target. So what this would allow me to do is potentially isolate certain components. So for example, we can make trigger control perfect, and we can make natural point of aim perfect, and we can just look at the size of the hold. So in this case, we intend to put all the shots in the middle of the target, and with perfect natural point of aim, our aim for every single one of these shots is at the center of the target. Now, our hold will vary left, right, up, and down, and then based on that hold, our trigger control is perfect, and our equipment is perfect, and there's no wind. So in this case, what we're looking at is we're looking at what would happen if we had an elite hold or an elite shooter hold and perfect everywhere else. What would that group look like if we were able to just isolate the size of the hold and adjust this? So we could change that to, say, an intermediate shooter or a novice shooter and just keep generating groups and getting a score. And so while it doesn't really seem to lead to very much, I think there might be some nuances that could be picked up based on doing that. And in addition to isolating the components of a shot like I'm doing here, I can quantify these components of a shot. And one thing that has always kind of bothered me are sometimes the people that will say that, for example, they'll talk about their rifle, for example, a rifle and ammo combo. This is very common. And they'll say that that their rifle and ammo shoot a half minute of angle all day long. And I like that. I think that's funny that someone will say all day long, because if you're at the range for an entire day, you could shoot, say, off a bench, I don't know, say 500 shots if you were there for most of the day. Well, out of that 500 shots, are all 500 going to be in a group that's half a minute of angle in size? I don't think so. But anyway, the other thing this allows me to do is quantify the components of a shot. So for example, I can change these variables here based on what I think is appropriate, and I can adjust these to where if I think these are incorrect, I can change them and get probably more true to life values for the outputs for the shots. For example, if everything here is perfect and I'm shooting this kind of rifle, what I can do is I can quantify my output, which means that instead of saying, well, you know, if I go from, say, a rifle or an ammo combo, an equipment combo that's pretty good, to one that's quality, with quality components, how much will I improve? How much will I get better as far as my group size? So in this case, I go from a group size that's like this, and I can keep generating multiple groups for more data. And then I go to this. Now, is that really correct? You know, is going from improved equipment quality to quality equipment quality, does it actually generate that kind of improvement? I don't know. That all depends on these numbers here. So garbage in, garbage out. But at least it's a starting point. So what I'm going to do is I'm going to continue on with this, and I will I'll make improvements on it. I will add in the other stages of fire so I could have an aggregate score for an entire course of fire. And then I would be able to isolate certain stages and certain components of those stages, and I don't know, just kind of play with it. So anyway, thanks for listening.
Well, that was just a little bit of insight into some of the things that go through my mind during the off season. When the snow's on the ground, there isn't a lot of shooting to be done. So what I do is I do a lot of thinking, and a lot of that thinking involves numbers, as you just saw. So if you're still awake during this, thank you, and hope you got something out of this. And if you want me to make more videos about things like this, let me know. Good luck and good shooting.